All right, so hi everyone. This is a TypeScript PR review sort of series that we want to try and do. The aim here of sort of providing people with some of the sort of insight that you get as a compiler engineer in trying to go through some of the PRs that we've done. Like TypeScript is now 7 years old, and I think there must be thousands of PRs to go through. So we sort of picked out a set of pull requests that add features that people generally love to TypeScript. And so for the first two, what we've decided to do is go and look through when JSDoc parsing was added into TypeScript. So the first one that we're going to be looking at is this PR that we have open here, which is 3291. And I think I'd like to introduce all of us. So as I'm already talking, I may as well. I'm Orta. I've been on the TypeScript team now for about 4 months. And I guess my general focus so far has been a lot of the website and documentation infrastructure. And we have 2 other people on the
line. Yeah, I'm Nathan. I've been on the TypeScript team since I think about 4 years ago, more or less. And yeah, so I work on JSDoc and definitely typed quite a bit.
I'm Andrew. I joined the team about 6 months ago. And in that time, I've kind of worked a little bit on everything, still kind of learning the ropes of all the different parts, but spent a lot of time in the language service and kind of editor experience things.
Nice. So we wanted to try and talk a little bit about the context around this pull request. Nathan, you were the closest to this at the time. What was going on in early 2015, and why did people think about even adding JSDoc support?
That's an interesting question. So early 2015, the ES6 sort of big push had just ended, and everybody was sort of fixing bugs. And I think they were sort of trying to find out what was next. You'll notice that Anders went off and did union types and then intersection types in the next year. And Cyrus started working on JS support. He ended up switching back to C#, I think if you look at his May 28th, so he switched back 2 or 3 weeks after this PR went in, which is why part 2 is done by Ryan and not Cyrus. I don't remember what emergency was happening in C#, but they suddenly needed Cyrus. So, yeah. So the previous 6 months before May 28th had been largely spent adding tons of ES6 features and trying to retrofit anything that didn't match what was already in TypeScript with whatever the committee had decided.
That makes sense. That was a big spec, right? The ES6.
Yeah, and TypeScript had some of the things, but it didn't match other things. And for example, modules were completely different from namespaces. And so all that had to be added. But there's plenty of other stuff too, like destructuring and things like that.
Cool. So why are we seeing this PR, right? There's 2 of them. You can see here in the comment, there's some code changes in this one, but this one only contains the parsing and none of the binding and checking.
Right. I think there's a disagreement about how to do the binding and checking at the time, because the binder sort of thinks of things in terms of containers, and the containers have a list of locals. And it wasn't clear whether to think of a JSDoc comment as a container that would sort of sit next to it. It basically provide types for the things that it was attached to, but in a weird sort of way in which it was hanging off the side. The way we eventually ended up doing, and you'll see this in the next PR, is instead of that, you just basically say, I saw some JSDoc, and then the binder goes through and binds the individual types it sees in the JSDoc, but the checker has to, at each point, decide whether it might be interested in looking up JSDoc and look at that up manually at each step. So there's no sort of unified representation of JSDoc in the binder. It just happens to walk through the tree and see some types in some places. And we can talk about that in more detail next time.
When this PR was made, was there already the kind of vision of where we are today with JSDoc, that you can do almost everything that you can do with TypeScript?
I think this was the first step of that vision.
Yeah.
Oh, sorry.
Yeah, I was just wondering whether that was kind of like the idea from the beginning that we were going to move towards everything, or if there was some just like baseline scenario that we wanted to support.
I mean, the long-term goal was pretty much where we are now. I think for the short term, about the first year or so, or year and a half of implementing this, the goal was simply to say we need to be the language service for JavaScript in VS and VS Code. And that means we need to have some kind of completions for JavaScript, which we did not have previously. And so there's a lot of work that Cyrus and Ryan and Mohammed and I did to get basic JavaScript understanding. And so there's sort of two users that we have in mind now and didn't necessarily back then. One is somebody who wants almost TypeScript-like performance on a JavaScript code base, and they want to be able to specify types and everything.
Get full faces.
And the other user is somebody who shows up with a bunch of JS and doesn't even know about TypeScript, and we want to give some reasonable completions there. And in the first year and a half, that second user was the one we cared most about, was just somebody with a bunch of JavaScript, and we should do the best that we can.
Cool.
That makes sense. So we have a working in debug setup so that we can sort of go through the actual code of the pull request. Nathan, do you think you can like share your screen, and we'll like what we're trying to do here is go through the code that has changed in the pull request in a way that like makes sense when you would be actually seeing it. So instead of sort of looking at a pull request and just starting at the top and reading the way down, we're trying to like at least understand it from a sort of implementation level. There's like, we've all talked about it beforehand and have a general sense of how it all flows. So hopefully this should feel pretty natural. At least I'm optimistic.
So let me share VS Code. Where is VS Code? We got Teams. Hold on while I find VS Code.
You know, it's got a little bluish icon. Unless you're on Insiders.
Here it is. Yep. Okay, I was confusing it with Emacs, I think. All right. Okay, so is that properly shared?
Yep, that's definitely the full screen.
Let's make sure that the right people are on there. Okay, good. And then we want debugging view, right. Okay, so we've got a breakpoint inside this worker. So you want to start with the debug then, and sort of just step through the core of the algorithm, and then we can look at the sort of ancillary stuff later.
Yeah, I think so.
Yeah.
Because this is the first time that JSDoc was supported at all, right?
Not exactly. So the language service parse the comments part of JSDoc.
Yeah.
So that you would, when you're doing quick info, we would have this really basic scanner that would look for @param, and inside of @param, it would attempt to match the parameter name to the parameter name inside the function parameter list, and then it would look for text after that, and just basically cut to end of line or something really simple. It was a super simple scanner, and it didn't do any types whatsoever. And that it also didn't represent anything inside of. It didn't create any AST nodes. It was just looking at trivia and parsing text in trivia. And this was a separate. Basically, we had two separate parsers for about 2 years there, a year and a half. Whenever it was that I took over the project, I smushed them together into one complicated parser. So the good news is that makes this parser easier to read because it only does types essentially.
Cool.
It doesn't care about comments.
Awesome. So the entry point is parse.js comment worker?
Yeah, basically. I mean, this is where all the actual work happens. So let me fire up the debugger here. Actually, is this too small? I bet this should probably be zoomed in. I don't know what resolution this video is going to be.
Good question. Maybe just do it 1 or 2. It's hard to say. It feels pretty good for me.
Okay.
But yeah, that feels better.
Okay. Yeah. Yep. So you can see that Cyrus enjoyed writing notes. He leaves like really long comments, texts. All right. So anyway, so parse.js comment worker. Why don't we just look at the source text? Okay. Yeah, that's great. So you can see the entire source. We're just going to snip out just the JSDoc for this thing. Yeah, the example program is kind of interesting, sort of. So we've got a function with a parameter. Oh, you can't see me pointing. Can you see me pointing?
We can see you pointing, yeah.
You can see me pointing with my pointer, but not with my finger.
In
cursor
Teams
is
you can,
good. The
but
finger
not inside
is no
VS
good.
Code.
Yeah, it's not so good. Okay, so you see NN. Eventually, next PR, we're going to see code that matches NN to NN here, and then tracks down the type. But right now, we're just going to be parsing it. And in fact, this function is just parsing this part. And this is what the start and end stuff is happening here. So this is kind of a start, and length is 47. So if we start stepping, what did end come out to be? 47. Okay. I'm confused here already. Start 0. Oh, yeah, right. This is the start of the.
That's the full comment, right?
Yeah, there's no other source text. So the very first character is in fact JSDoc. Okay. Some asserts, blah, blah, blah. This is not super interesting. Okay.
I'm always interested in this. Like, why are these char code ats rather than just like a string before? Is that like a speed thing?
I'm pretty sure that's a speed thing. I don't know for a fact. Besides, you'd have to write a regex to be ES5 compatible. Or ES3? We were ES3 compatible at the time. Okay. So you wouldn't have anything ES5 or later.
Oh, yeah, like in the runtime. Yeah, that makes sense.
Yeah, so do you really want to do content.match and then pass a regex that does that? I mean, probably actually be as fast as this, but you'd have a regex.
This is specific, yeah.
So here we are with char code at. I mean, I don't know. I think also that this is based on the scanner style, and the scanner manipulates char codes with an enum, essentially. It's written in a very classic scanner style.
Cool.
So yeah, we should point out that this is a scanner that Cyrus sort of dumped into the middle of a parser, which is not how you normally build a compiler, but this was supposed to be sort of a small start for the thing, so it's sort of okay to have a scanner in there. But it makes some of the code kind of look really low level, like we have this position thing that tracks where we are, and it gets plus all over the place. So, all right, so can parse tag and scene asterisk are essentially our state maintenance variables. We're building a state machine here. And later versions actually just have an enum where you tick through the various states of the state machine. But here we're using two booleans instead. The important thing is really just can parse tag. So let's take a look. If you all think of an interesting watch, you might add a watch here. I'm not sure what it would be, but
yeah, I don't know.
So we're going to start off inside the */ right here. And we're going to grab a character. What is our character? 13, which is a new line, I believe. Okay, so it's not an @ so that's where we would be going if we were parsing things. It is a line break, so we should be right here on this thing. So now we're in a state where we can parse a tag because we just started a new line, but we have not seen an asterisk yet. So we're looking for this leading asterisk on the param thing here.
Yeah.
And we're going to skip over it.
This is perfect. I get it. It's like a state machine. It's working its way through the first new line, and then the next one is like, I need the star so I can look at the next string that's coming up. Yeah.
This is, as an aficionado of state machines, I don't really like the state machine very much, but it's definitely a state machine. Asking about state machines sometimes. So we should be looking at white space now. Yeah, no 10's another line break. Anyway, Windows. I'm not sure that would be, I think our program might debug slightly differently on a non-Windows machine, but here we are. All right, so now we should have a space. Yes, we have a space, which means we're going to take the white space here. All right, now we should see our first asterisk. 42, sounds like an asterisk, probably.
Just memorize those all. I guess you would, right?
Yeah, there's only 3 to choose from, so let's see if I was right. Yeah, okay, so if we've seen an asterisk, then we've switched. If you have 2 asterisks in a row, it means that you have malformed something, and you're not looking for @ anymore. You're just looking for comments. So you just say, well, Oh, we haven't, but we didn't take that case. Instead, you flip string asterisk to true. You continue, you're going to see a space. This is the part where streaming is kind of slowing things down because.
But then no one would be able to see it.
That's true. That is true. Okay, so now we should have an at 64. But that doesn't quite sound at-like, but I guess it is. All right, so yeah, so now we're going to parse a tag. So we are here, right here. And once we've seen the at, we sort of switch out of scanner mode and into parser mode. We start parsing more things at once, basically. It also makes it harder to visualize where we are because there's no string up here anymore telling us what we're seeing. But okay.
Possible it's just further in the context. I can look for it. Oh yeah, I can add that to watch. That's okay.
Okay, great.
Are watches shared? I added a couple. Nope, they're not.
They're not. Okay, just tell me what you like.
Content.slice with pose is pretty good. So it'll show you the rest of the content starting at where we are.
Yeah. How do you delete something? Just delete. Okay.
Someone's watching this for the first time and being like, "What?"
So the general structure of a parser function in the parser, you create a node at the beginning, given whatever position you're in. You fill in some stuff with side effects. You possibly calling some sub functions that do some parsing, and at the end you usually call finish node. I think for the JSDoc parser, it's slightly different at this point in history. So basically, we're just going to create a node, it has two properties essentially. It has the thing that it is plus where it happened, and then we fill in some additional properties like the end and.
So this node is just the at token, right? Identifier.
Yes. I'm confused then. So the tag should be the actual thing.
Yeah, I think it moves on, and then it says the tag is the next thing when I looked at it.
Okay. Yeah, that's what it was. So my description was not super accurate.
Yeah.
But it's generally what's happening inside of parsing functions. Okay, so scan identifier. I don't really want to jump into the main parsing code. Scan identifier does what it sounds like it does. So if we look at tag name is going to be a node with a position in the end and a text. If we didn't find one, then we just assume that something went wrong. But we did find one, so now we're going to look at handle tag. If you notice at this point in history, we supported 1, 2, 3, 4 tags, which are still like the basic 4 tags.
They're the ones that matter, you know?
Say what?
They're the ones that matter, you know?
Yeah, I mean, they are.
They're the ones that have types.
Yeah. Or they can affect the type system, maybe, in a way that we would expect.
Say what?
I'm just agreeing.
Oh, okay. I'll turn up the volume a little bit here. Okay, so we know that we're in a param tag at this point. Yeah, this is cool. We can see content close over at any point. So the first thing we're going to do is expect to see a type expression. Already we supported type expressions afterwards. In other words, you can get the order wrong according to at least the standard, and you can say in followed by number because basically we assumed people would get confused when they were trying to write TypeScript-esque JSDoc comments. In this case, we're going to follow the standard path because we have a correctly formatted JSDoc comment, but whatever.
Cool.
I love how many Easter eggs of like wrong code the parser understands.
Oh man, yeah. Well, there weren't as many back at this point. So. Okay, so skip whitespace, I believe, is a new function. I'm pretty sure. I'm going to jump in. Yeah. So this got added here because previously the parser never had to skip whitespace because the scanner, the main TypeScript scanner, just skips whitespace for you. So I'm gonna jump back out. I don't really care about seeing that. I just thought it was interesting to point out. All right. So the first thing you do is you look for a brace, and we have a brace. And next we decide we are going to parse this as a type expression. Okay, so this is basically sets the scan. Wait.
Yeah, I looked at this. There's a scanner inside the expression checker. It uses the original one.
That's interesting. I didn't think we needed to do this here.
Yeah, because this PR sets adds a bunch of tokens, I think, to the original scanner, and that's kind of how it does this part of its work.
Interesting. Okay. All right. Well.
So
Okay.
maybe they're just trying to take some shortcuts because they knew a lot of it was also like temporary.
I think because we have to scan and parse like normal TypeScript things inside this expression potentially.
Well, except we don't in this at this point in history.
We don't for some, but I think that we still do for like keywords, right? Like string or number.
Maybe so. I thought those were still parsed by this bespoke code, but I could easily be wrong. It may well be because we're still calling mixed token, for example.
Yeah. So I think they use it for its tokenizing.
Yeah.
And just call it at that. Yeah.
We definitely call next token to avoid having to step through character by character like we used to be doing. So the outer code steps by character. This stuff is chunky through token by token, which is definitely nicer. Unfortunately, can I even see? Oh, right. So unfortunately, we're just getting a token code that's pretty opaque.
Yeah.
Is that going to be important? I don't know if that's actually that important. So parse expected says it gives you a token, and if it's there, you continue. If it doesn't, it throws and tries to get a reasonable error. So imagine here we have something like this, right? So we're expecting this open brace right here. And then we're going to start parsing this tuple type.
Yeah.
All right, so then we step in here. We have a top level type, which we step into. And then a basic type, which we step into. And this is a recursive descent parser. This is what they do. And finally, we look at the token that we found, which is 18. And that turns out to be an open bracket token. And at that time, open bracket could only mean a tuple type. I don't think that's necessarily true, but I mean, for the start of a type, that is still true. So, right. So we're going to parse the tuple type. And again, you create a node, you parse some stuff, you parse some more stuff, and at the end, you say finish node of the result.
What is checking for trailing comma doing in that case? Is that at the end of the identifier?
You know, I don't know. Let's jump in there. I'm actually, I don't know. Are you interested in seeing the actual parsing of number comma number? I don't know how much time we have. I was expecting to skip over that.
Yeah, I think we should skip over that. We're at 25 minutes. Well, 20
parse delimited list is not rocket science. Well, I mean, it's complicated, but it's a pretty well-known thing. You have a list of things. You tell it what the sort of what your context is. If you're tuple types, you're supposed to be separated by commas and terminated by a square bracket. All right, so we were interested in check for trailing comma. So,
it's an error message.
Oh, that's right. We jammed all sorts of custom properties on lists back then. I don't think we do that anymore. I'm not sure. So basically, parse delimited list also jams some additional properties onto the list that you created, and then the parser can check that. Back then, I guess trailing comma was not allowed, because this is
now.
Okay, so as of this point, we've made it past bracket number comma number, and we're looking for this final close bracket token, which we find, and then we call finish node. And finish node is just sort of some setup stuff. There's some flags you might set. It's not super interesting. It sort of gets into the nitty gritty of positioning and so on. But that's the basic structure of a parser function. Okay, so now we're going to pop all the way back out of all of this recursive descent. And we're going to check for postfix kinds of things, like arrays would have an open bracket if we'd had an array type like this. We don't, so we skip to the next one. We also support trailing question mark because this gives you a JSDoc nullable type. Don't have one of those. We support JSDoc non-nullable type, which we still support. It has no semantic meaning even today. in TypeScript. But we don't find anything of those, so we just break.
But you can have strict mode on JavaScript with JSDoc, right?
But our type system assumes that if you don't say anything, then you're by default non-nullable.
Oh yeah, that makes sense.
It's Clojure's type system assumes if you don't say anything, you could be nullable or not nullable, and it doesn't really know. And so you have to use bang to indicate that you're not nullable.
Swift has something like that, but for class initialization, like initialization of properties on classes or fields. There you go, fields on classes.
Interesting.
So it's like it might not be set in the constructor, but it's definitely going to exist when someone uses it.
I mean, we have something like that, but I think it's more of a thing to get the compiler to stop pointing at you more than anything.
Yeah.
All right. So okay, now we popped out one level. Now we're going to parse sort of. Well, I'm not entirely sure of the structure here, why it was done this way, but now we're going to parse possible unions. We look for a pipe. If we see a pipe, then we would start parsing something else like that, or number or string. But we don't find anything like that. And it also supports postfix equals, which is a Clojure thing, meaning it's called an optional type, which the name.
Oh, Google Clojure. Yeah.
Say what?
Sorry, Google Clojure.
Oh yeah,
like Clojure, the programming language first.
So compatibility with Google Clojure was a feature that we had in mind as well. It's still sort of a third group of people.
Yeah.
Okay, so now we should be almost all the way out of parsing the type. Okay. Yeah, so parse JSDoc type expression is almost done. We're expecting the close brace right there. Fix up parent references is a hack which we removed in the next PR, but it basically says make sure all the parent pointers are set because the parent pointers are not set during parsing downward. And finish node does the flag setting and position setting. Okay, and then do some more position setting. I'm not sure why that was being done. Oh wait, this one we're transitioning from the normal parser, which updates position in itself back to our manually written scanner. And so we take the end expression and update the position of the scanner so we know that we'd skipped over this. So now notice over here, content.slice, we've skipped over the braces and now we're looking at the name of the parameter.
This is a really interesting handoff.
Yeah, it's stayed interesting in a bad way, unfortunately. But yeah, it's the join between the two is a bit uneasy. So yeah. All right, so we're back in param tag, and we've got got the type expression of the param tag, and if you remember, a param tag is also going to have a name and possibly some text. So we're going to look at name next. And the name can be in brackets to indicate that it's optional, but it's not going to find that. So we're going to skip over that. We just scan for identifier again, and name will come in as. Did it come in? Yeah, there it is. In.
Yeah. So scan identifier is useful here because there are rules about what a string and variable name or something like what a variable name could be inside JavaScript, right? So this makes it consistent everywhere.
Right. Yeah, you're not just looking for anything but white space, essentially. Okay, so at this point, we check to see if we've already found a type expression. In other words, if we're seeing normal JSDoc syntax instead of the TypeScript style. What's the type afterwards? And we've already got it, so we're just going to post name. Oh, that's right. So there are two separate variables, and I think there's even stored separately. Yeah, they were. Oh man, this is so weird and bad. Okay.
Oh, yeah.
For complicated reasons, this was actually the easiest way to make it work in the parser at the time. If there was if you put the parameter name first, it got it put in a separate property than if you put the parameter name last, compared to the type expression. And then all the code everywhere else had to then account for
Check
that.
both.
Yeah.
Wait, so
say what?
So wait, where does that? What does that look like in terms of like actual JSDoc? So it's like you could
right.
switch out the comment and the types.
So say you'd written at param this. It's extremely tempting for a TypeScript to write something like this. At param in, and then put the type. And say, well, that's how you're supposed to do it, right? Because you put the type last.
It looks like this will parse with a name in both positions too.
It might. I mean, there's no
guarded
guarantee
against?
this code wasn't bugged.
Like, yeah, it just pulls out the first character of the first word of your comment, basically.
And it was hard to tell back then because you, of course, don't parse comments. Let's see here. So if you have a type expression, you jam it in there. Otherwise, you assume that the first name, and then you parse another type. That might be right. I'm not sure. Should I move on?
Yeah, go for it.
Okay. So here we think we're in the normal JSDoc syntax mode, and we don't try to parse another type. Okay, so we create a node, we set a bunch of properties, and then we finish the node. So that's fairly normal, except we didn't create this at the beginning because we're managing all our own positions since we have our own scanner. We're almost done, I think.
Yeah.
So we've handled the param tag. Now we add the tag, which is actually pretty simple. We just find the parent tag, and if it doesn't have a tags array, then we create one. We set some positions because I don't think we do that anymore, but we might, and we push it into the end. And then this parent tag is the thing that's going to be returned, I think. I'm not sure. Let's take a look. So tags is up there, and then at the end, create JSDoc comment. Yeah, you create a node, it's called JSDoc comment, and you jam on the node, the tags, and then return the thing. Okay, so we're looking at this. I don't want to do too much more because it gets pretty repetitive pretty fast. But let me just step through to show that it doesn't actually do anything with comments. So we parse the tag, start over at the top of the loop, bump the position. Now we're going to see a dash, which is not any of the things we recognize. Oh, I'm sorry, we saw a space. Now we'll see a dash. Okay, so in that case, we have this fallback that says, oh, you're in doc comment text. Stop parsing tags until we see a new line. And so then we're going to parse it. Like, this is where it gets really boring because we're going to go character by character over a bunch of stuff.
Maybe hit a breakpoint at the bottom. Yeah. I'll pop out. Yeah.
I'll see if I can hit that breakpoint. Yeah. Okay. So let's just jump in and see. So we create the JSDoc comment. That's sort of the parent of the whole thing. Oh, that's not what I wanted. So you can see that the structure we've created is, in fact, it has post parameter name, tag name, so on and so on.
And we don't even save the comment text, right?
Nope.
Just totally thrown away.
Yeah, it's just for type parsing at this point. And if you found a comment, then you set the parent pointers on the comment, and then you say comment.parent equal parent. And hopefully somebody then puts the comment onto the actual node. Yes, good. Okay.
Yeah.
Yeah.
I think this is where we started, basically. Yeah.
Yeah, and here we are. So there's only one comment to this thing, so we're done. I think that's probably a good place to stop it, actually, because now we're going to sort of bump up through, just visiting the rest of the file.
Yeah.
All right.
Okay, cool. So there was only one more sort of aspect of this that we'd like to look over, which is like how did someone test these changes? Like how was how was all these parsers tested, and how was the scanner tested? So I can tell you the file name if you want to know it, but roughly it's all the unit tests inside.
Yeah. Okay.
The JSDoc parsing.ts.
Okay.
So unit tests, cases, unit tests, JSDoc parsing.
Hold on. My Linux instincts are failing me here because that works just fine on Linux. Okay, I think I have to use the tree. This is the tree? No, this is not the tree. This is the tree.
Yeah.
Oh, I don't even have the right folder open. Hold on. I'm just gonna use this thing. Suffer. Okay, so where is it?
Tests, unit tests, cases, and then unit tests.
Oh wow, this thing used to look different. Oh, JSDoc parsing.
So just full files in there. Nice. Yeah, that's the one.
Okay, now Windows is refreshing some cache. Oh yes, it's the large view. My favorite view.
Perfect.
All right.
Cool. Let's let them mine too.
So did you have an? I didn't really look too close at this file. So if you have an idea.
Yeah. There's really not too much that's actually like this testing style is extremely simple, and ideally anyone that's ever wrote tests before should totally understand what we're looking at. Basically, we just basically have a bunch of describe blocks, and you have this passes correctly, and then it tries to understand what the AST nodes are.
Oh, so you just give it a string and you give it an AST, and you're like, that's the AST.
Yep, that's really what all of these tests are. You scroll down a little bit and it starts to hit like some incorrect ones. This is how I actually verified that it wasn't, taking the comments and putting those into an AST at all either. Like, what I liked about these was they're very much like, here's an input, here's an output, and perfectly readable.
Good point. Yeah, I mean they're a bear to maintain, but they are pretty easy to read.
Yeah, I guess it's because it predates baselines.
Yeah, you couldn't baseline JavaScript back then. And you couldn't run / on JavaScript at that time either. So this was a good first step.
Yeah.
It's going and going. I'm going to jump down to some of the more complicated ones, maybe. So I've got a type tag. Yeah, they get complicated.
Yeah.
Huh, okay.
It's nice and simple.
I mean, to be fair to our viewers, very few of our tests are structured this way. And instead you get this sort of deceptively simple, here's a file, and then you have to know that it generates a baseline. It's in the actual test.
But don't worry, we'll have to see those eventually at this rate.
Yeah.
So it's a nice, gentle introduction to the testing in TypeScript.
Yeah.
Feel like that's more or less everything that I wanted to cover about this PR. So what PR was that? 3291. So I guess to go over it in summary, it was the first PR to sort of add like JSDoc, like actual parsing used by taking like real tokens out of the comment itself in order to generate an AST that could then be available for other tools to use, for other parts of the compiler to use in different places. This PR didn't actually have any of these other places using it, but it was available if they actually chose to do it. Does that feel about right?
Yeah, I think so. I mean, it was useful to have an AST in theory for anybody, but yeah, the intent was to use it in the checker.
Cool.
And in fact, I think for the next PR we'll see it's not actually that big. This PR is way more lines of code, I think. Yeah. Pretty sure.
Okay, that's good.
Yeah.
All right. Thank you everyone for doing this, and thank you people that actually continued to watch all the way through. Felt like it worked quite well for me, so maybe we should get this online.
Yeah.
Ciao everyone.
See ya.
Bye.